All right. Hello, everybody. So today we are officially going to start with some lessons on chapter 1. So this is section 1.1. We're going to talk about the parent functions, their families, basic transformations, and then most importantly, domain and range using interval notation. The truth is there's a lot of graphs and a lot of discussion, so there might not be a ton for you to write down. So of course, just make sure that you're listening carefully, asking questions if you have them, and then my advice would be to pull this video back up as you attempt tonight's homework. So first, as a reminder, these are the 8 parent functions. You've probably seen at least half of them once or twice. If some of them are brand new, no worries. Some of them are so important, they get their very own chapters later on. But so here in A, this is an example of the absolute function graph. It looks like a V. Over here in graph B, this is what's called the square root function graph. Here in example C, this is what's called the constant function. In D, this is the exponential function. In E, this is called the cubic function. In F, this is called the linear function. G is the reciprocal function, and H is, of course, the quadratic function. So some of these, if they're brand new, no worries, because like I said, some of them are so important, they're going to get their very own chapter. Which ones are we going to focus on? We are going to focus on these 4 right here. So the constant, which is, of course, a horizontal line, and they start off with y equals or f of x equals 1. Then the linear function, so that's y equals mx plus b with a slope of positive 1 and a y-intercept of 0. The absolute value, hopefully you remember an absolute value makes everything positive, and that's why it has a V shape. And then finally the quadratic, which again makes everything positive, but it forms a U shape as opposed to being a V. Notice underneath here, they have the domain and range, but notice that these are not in interval notation, which is the notation that we want to use going forward. So please make sure you're aware. Anything that says all real numbers, remember, of course, that the way that you say all real numbers in interval notation would be negative infinity to infinity. If you have a lonely little value like y equals just 1, literally the only range is 1, you can either just write it as y equals 1, or you can put it in a set of brackets, just a 1. We'll talk more about that later. Then for the answers that are y is greater than or equal to 0, well, if you're greater than or equal to 0, it means you're starting at 0, getting infinitely large. Parentheses for your infinities, and a bracket for your 0 because it's included. Then transformations. I'm sure you've heard of transformations before. Remember that a transformation changes the size, shape, position, and orientation of a graph. A translation only changes the graph to move horizontally or vertically, but it does not change its size, shape, or orientation. So a transformation is when you stretch it and shrink it. A translation is really more of just you move it. So transformations are going to be a huge part of this year, and we are going to see it in many different ways. So I'm going to go ahead and pull up some graphs here for you, the 4 parent functions in particular. So starting off with the constant function, this is the function y equals 1. If we want to know where that function came from, well, here's a table. I'm going to plug in a couple of x's like -2, -1, 0, 1, and 2. And no matter what I plug in, all I can get out is 1. So whenever you're in doubt, feel free to just go ahead and make a little table of values. Then let's talk about how the graph y equals 1 can change. Well, now suppose I graphed y equals -1 on the same set of axes. Notice that it looks the same, except now it's underneath the x-axis. Why did that happen? Well, because there was a reflection. That's an example of a transformation, and in this case, it's a reflection over the x-axis. If we get rid of that and instead we graph y equals 5, notice that compared to the original, it moved up 4 units. So that is a translation where you simply moved the graph up 4 units. Let's talk about the linear function, y equals x. Remember, this is really just y equals mx plus b with a slope of 1 and a y-intercept of 0. How did I get that? Well, pull up the table. plug in a couple of X's, and you get back the same exact Y values. So again, when in doubt, make a table. What kinds of cool things can I do to this? Well, if I graph Y equals negative X on the same set of axes, again, notice it's a reflection over the X axis. What about Y equals X plus 2? Look at the blue graph. It is 2 units up compared to the original. The next graph is 3 units down compared to the original. By putting a 2 out front, I stretch the graph and make it steeper. By putting a 1/3, I actually make the graph less steep. So again, these are just quick examples of all the transformations. Then consider the absolute value function. And again, where do I get that? Well, pull up the table. Whatever value of X you plug in, you get back the same value, but only positive. That's why the graph is only in the upper half. Compare that to a negative out front, reflects it over the X-axis. Compare that to a +3, it goes up 3 units. Compare it to a -1, it goes down 1 unit. Again, these are examples of the transformations. Inside the absolute value moves it 4 spots to the left. Whenever stuff is on the inside, it's always the opposite. Notice that a 1/2 makes the absolute value less steep, which means that it looks wider. For now, you just want to know that these transformations are a thing. And in the next PowerPoint, you're going to kind of start writing them down more officially. Finally, the quadratic. And again, where does that come from? Well, pull up the table. No matter what you plug in for X, you have to square it, which turns it positive. When in doubt, make a table. So hopefully now you can predict what's going to happen. If I click to show the second graph, boom, reflection over the X-axis. +5 moves it up 5. -4 moves it down 4. And notice that those values are on the outside. When they're on the inside, you're going left and right, but in the opposite. So -3 actually means right 3. +1 actually means 1 to the left. So again, you're going to start looking at those transformations more officially tomorrow. And finally, a 5, if you put a 5, it actually makes the graph appear much, much skinnier or much, much narrower. So let's go ahead and go back to our PowerPoint. And the first thing I want to ask you is I just want to ask you, look at these pictures and tell me what function family the graph belongs to, and then try to tell me in words what some of the changes are. So taking a look at the graph on the left, the fact that it's a U shape, hopefully, oops, sorry, I got to bring back my pen. Hopefully the U shape is how you know that this is a quadratic graph. The quadratic parent function, which we just went over, usually starts here. So the fact that it's now starting at -4 means it appears that this graph moved 4 to the left. Look at the graph on the right. The fact that it is a V shape means we know that it's part of the absolute value family. The absolute value graph that we just saw usually starts here. So think to yourself, what are some changes? Well, it appears to have gone left 2 units. And because it's upside down, that means there was a reflection over the X-axis. Remember, the X-axis is the one that goes from left to right. 2 more functions. So on the left side, if it's a horizontal line, that is the constant function. The constant function that we started with today was at Y equals 1. So what's the change for the blue function? Looks to me like it's up 2. Then the graph on the right, it normally looks like this. It's the linear function. So what has changed? Well, it was reflected over the X-axis, and it looks like there was a change of the Y-intercept up a couple of different units, 1, 2, 3, 4, 5, 6 units. Again, you are more officially going to describe those transformations in the next PowerPoint, but for now, you just have to be able to identify what is the function family and try to describe in words what's happening. The main goal of today is for you to be able to find domain and range, not only be able to identify it, but most importantly, be able to express it in interval notation. So as a reminder from a graph, domain is always X, which means left to right. Range is always Y, which means up to down. Here are some visuals of what's happening. So take a look at the blue graph here in this example. It starts on the left side with an open circle. It ends on the right side with an open circle. The domain is shown here at the bottom. It's from -3 to 3. And because of the fact that there are open circles, it means that it's not included. So here's the answer written as an inequality. We want to convert that to interval notation. So how do we convert that to interval notation? Well, if you're starting from -3 and ending at +3, then that's your start and your finish because of the open circles, parentheses. Then consider the range. So the range goes from the lowest number to the highest number. The lowest number is -2. The highest value is 4. That's how you would write it as an inequality. And we're using a y because range is always y values. The beauty of interval notation is you don't need a variable. So it's just implied. So how do you say in interval notation, starting at -2, ending at 4, and not including the points? Well, you use parentheses and it looks like that. Let's do another one. So here you have an upside down quadratic. Notice for the quadratic here, you cannot tell a clear starting x or a clear starting or a clear ending x. That implies that there are arrows on the ends of this graph, which means the graph goes on forever. So if the graph goes on forever to the left and goes on forever to the right, that means that the domain is going to be all real numbers. Think for a second, how do you say all real numbers in interval notation? You go from the smallest number to the largest number and always parentheses. Consider the range though. So the range is y values. So even though as you go down, it's getting smaller and smaller and smaller, there is a clear highest value. The graph does not go above 2. So that means it's everything less than or equal to 2. How do you say that as an inequality? You say y is less than or equal to 2. How do you say that in interval notation? Well, if you're getting less than or equal to 2, the lowest you can go is -infinity. The biggest you can be is 2. Never include infinities. Include the 2 because it's a closed circle. One more, take a look here. Again, this is now one of the linear functions. There's no open circle and no closed circle. That implies the graph goes on and on forever from left to right, and it implies the graph goes on and on forever from bottom to top. So all real numbers for everybody, for the x, for domain, and also for the range. So how would you write each one as all real numbers? You would write both of them as -infinity to infinity. So now that you've seen some examples that kind of have a little hint, what would it look like to start from scratch? So this is what the majority of your homework tonight is going to be. Here's a picture. Write the domain and range using interval notation. If it would help you to start by writing it with an inequality, do so. If you're, a rock star, you can try to just jump right to the interval notation. So starting with the domain for the graph on the left, here's where the first x is. Here's where the last x is. So the starting x is -1, include the closed circle. The largest x is 4, don't include the open circle. Then for the range, here's the lowest y, here's the highest y. So the lowest y is 1, include it because of the closed circle. What's the highest y? 6. And don't include it because of the open circle. How about the graph on the right? Domain means x's. Here's the first x, here's the last x. The smallest x appears to be -2, where the largest is +2, because they're open circles, parentheses for everybody. How about the range? Here's the lowest y value, here's the highest y value. So the lowest y value is -3. Since it actually touches that, you're going to use a bracket. The highest y value is on the x-axis. That's 0. Because of the fact that it's an open circle, you're going to use a parentheses. Two more, and these graphs should look familiar, but now we're talking domain and range. So domain is left to right. Again, arrows are implied if there are no open circles and closed circles. So domain is left to right. Because there's no clear beginning and no clear end, that means everybody is invited to the party and it's an all real number situation. Range is a little different. You can clearly see where the lowest y value is. Remember, the y value is 0. -4 is the x value. We want the y value. So starting at 0, and because it's a point, you're going to go ahead and include it. And then it gets bigger and bigger and bigger and bigger, and we call that infinity. Okay, and that's a parentheses where this is a bracket. How about the last one? So domain and range. So for the domain, left to right, the arrows on both sides imply that it is an all real number situation. How about the range? So the lowest y value keeps going down, 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 but the highest y value is right here. That y value is 0. Remember, range is always the y value. So if you're starting at 0 and going down, 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 what's the lowest you can go? -infinity. What's the highest you can go? 0. And because it's actually a point, you're going to go ahead and include it. Last two, domain and range. So the one on the left is pretty interesting. So again, it implies that there are arrows on both ends. So if there are arrows on both ends from left to right, then the domain is an all real number situation. And the range, the only y value that you get, no matter where you stop on the graph, is 3. Here you get 3. Y equals 3, y equals 3, y equals 3. That means the only value of the range is 3. In interval notation, you can either write that as a 3 in brackets, or sometimes your teacher might just let you say y equals 3. Personally, I prefer this one.